And welcome back to Mr. Gregoris Math. Today we're doing a little bit of a different video because there's not going to be as much writing. We're going to be taking a look at a few different blocks I have here. And if you remember playing with the Rubik's Cube when you were younger, this is very much like a Rubik's Cube, except for, I cheated and all of the colors are green. Haha, so that means it's already set. This is a smaller cube, and this is, of course, the base cube. Let's start with this guy right here. So this is a 1 by 1 by 1 cube. If we just assume that it has a height of 1, then we can actually talk about this thing's volume. So I'm going to write it down here. I'm going to write its volume is 1 cube. Oh, sorry. And we can talk about its surface area as well, too. So it has a side length of 1 and another side length of 1. So the area of one face is 1 unit. But I have 6 faces, so its surface area is going to be 6 faces. Now, the volume is a 3-dimensional measure. Meanwhile, the surface area is a 1-dimensional measure. Sorry, 2-dimensional measure. I also have a 1-dimensional measure as well, too. It's side length. So its side length is going to be 1 unit. Now, of course, these would be different measurements if we were actually measuring this in centimeters. We'd be talking in this one about something like centimeters cubed. We'd be talking in this one about like centimeters squared. And in this one about centimeters. And I'm going to put a little 1 there just so we can see that 1-dimensional units have 1 as an exponent on the measure. 2-dimensional units have 2. And 3-dimensional units have 3. These exponents are going to come in handy in just a second. So can we agree that this cube is twice the scale of this one? So I've taken it and I've blown up every dimension. I've doubled its height, I've doubled its width, and I've doubled its length. And so this is exactly 2 times bigger because every single dimension of this has been doubled. Now, that means that its side length is going to be doubled. So it's going to be 2 units. Now, to get from 1 to 2 is a very simple calculation. All I did was take the original and multiply by the scale. Now, interestingly, that does not work for the surface area. So if remember, we counted 6 faces for the surface area of this, because 1, 2, 3, 4, 5, and then 6 on the backside. For this one, I have 4 faces right here, and then another 4 faces, another 4 faces, another 4 faces. So far I'm at 16. There's 20, and there's 24. So if I'm talking about my surface area, I now find that I have 24 faces. And this brings up a little bit of a problem, because 1 times 2 is 2. That was easy enough. But 6 times 2 is 12, not 24. So what happened? Well, because faces is a dimension of 2, I didn't just multiply by the scale for the surface area. For this one, I multiplied by the scale squared. So I multiplied 6 by the scale, which was 2. I multiplied that by 2 squared. So 2 squared is 4. So 6 times 4 is 24 faces. Now let's see what happens with the volume. Do I also have to multiply that by 24? Well, how many cubes does this one break apart into? I realize I'm doing this off video, so you might think there's a little movie magic here, but there's no movie magic at all. I think you would have predicted that this is going to be 8 cubes. So if I take these 8 cubes, you could see how I could easily put them back together. My volume here is 8 cubes. So I multiplied my side length by the scale, my surface area by the scale squared. What did I have to multiply 1 by to get it to 8? Well, that's the scale cubed, because remember, volume is a cubic measurement. So 8 is equal to 1 times 2, the scale cubed. So that's how I can predict what my new volume is going to be. I take my old volume and I multiply it by my scale cubed. And this gets me my new volume. Okay, so we've extended this to something that's doubled in size. And we'll just kind of quickly put this block back together so that it's not tripping all over the place. And I'm not going to take apart my large block. Now I can put that aside. But I have a large block here, and I'd like to be able to calculate all of those same measurements of it. So I'd like to be able to calculate its side length, its surface area, and its volume. So what I'm going to do now is I'm going to remove this talking part, and I'm just going to go back to a formula like this. So the old side length was 1, but now that I'm making it 3 times larger, my new side length is going to be 1 times 3 to the power 1, because that's a one-dimensional measurement, and my scale now is 3. So that means my new side length is going to be equal to 3. And that was pretty simple for me to calculate. I could have also just counted it. Now for my surface area, my old surface area was 6 faces, but my scale was 3, and area is a power 2 because it's centimeters squared. So 3 to the power 2 is 9, and 9 times 6 is 54. So I now have 54 faces here. So I have 3 units of side length, 54 faces, and you can take your time to count them all up, but there's 9 on each side and 6 sides on a cube, and 9 times 6 is 54. And lastly, my volume. My original volume was 1, so I'll bring that up here. And I'm going to multiply by my scale, but because volume is a 3-dimensional measure, I'm going to multiply by my scale to the power 3, and this is going to get me my new volume. So 1 times 3 to the power 3 is equal to 27 cubes. And I guess to finish off the video, I can talk about hitting like and subscribe. And don't forget to ring that notification bell. I do sell my own version of unit cubes. They are invisible, have 0 mass and 0 volume. But the nice part is, the price is they cost nothing. So that's just a little bit of sarcasm to finish off the video here for you as I try and break apart all these cubes to count them up. Now, I don't think I'm going to have enough room on video. And man, these things are harder to get apart than they actually seem to be. But let's see if we can organize this into an easy way to count 27. So there's 5, there's 10, there's 15, there's 20, there's 25, 20, sorry, did I count that right? Oh, I forgot that extra cube that belonged to this one. There's my 27. So I have 27 cubes that made up my volume that I expected to have. Join us next time. Take care.